The title of my lecture, Space-Time Cdons. Here I'll tell you about unusual 16-component scalar vector space-time objects which take into account properties of physical quantities in relation to the space-time inversion. The plan of my lecture consists of several points. First, I would like to recall you shortly about Macfarlane quaternions and space-time quaternions. Then I'll tell you about space-time Cdons, and we consider their properties, rotation of Cdon, space-time inversion, and Lorentz transformations. So, Macfarlane quaternions consist of scalar path and vector path. Unit vectors A1, A2, and A3 have the specific rules of multiplication and commutation. The squares of A vectors are equal to 1. If we multiply A1 on A3, then we obtain IA3, where I is imaginary unit. If we multiply A2 on A1, we obtain minus IA3. The algebra of A elements is anticommutative. The rules of multiplication and commutation can be represented as the following table for convenience. The main advantage of Macfarlane quaternions is that there is so-called Clifford product of vectors. If we have two vectors A and B, then Clifford product of vectors is equal to the sum of scalar and vector products. Space-time quaternions. Space-time quaternion consists of two paths, scalar path and so-called space-time path. The E basis, ET, ER, and ETR have the same rules of multiplication and commutation as the rules of elements of Macfarlane algebra, but the properties of these elements are different. ET is a time unit, which is changed under time inversion. ER is the space unit, which is changed under space inversion. ETR is space-time unit, which is changed under space and time inversion. I would like to emphasize that E elements and A elements is commutative between each other. So there is the commutation between E and A elements. Okay, space-time Cdons. All physical values, scalar and vectors, can be represented as the four different groups. Absolute scalars and absolute vectors are not transformed under spatial and time inversion. Time scalars and time vectors are changed in sign under time inversion and are not transformed under spatial inversion. Space scalars and space vectors are changed under spatial inversion and are not transformed under time inversion. And at last, space-time scalars and space-time vectors are changed under spatial and time inversion. Here indexes T and R indicate the transformation which change the corresponding values, T for time inversion and R for spatial inversion. All these values can be integrated in one space-time object, so-called space-time Cdon. Space-time Cdon consists of four scalars, A, B, C, and D, and four vectors, A, B, C, and D. Space-time Cdons can be represented in the E basis in the following way. Okay. If we denote the space-time scalar as null, as the sum of A, B, C, D component, and space-time vector S as the sum of vectors A, B, C, and D, then Cdon can be represented in the form of Macfarlane quaternions. Complicated, very complicated. Macfarlane quaternions consist of scalar and vector path. Okay, rotation of Cdon. rotation of CDON is carried out using so-called operators of rotation. Here, theta is the angle of rotation and n is the unit vectors which defines axis of rotation. The transform CDON is obtained by multiplication initial CDON on operators of rotation. Since CDON consists of scalar path and vector path, and scalar path don't transform under rotation, then rotation of CDON is reduced to rotation of vector path only. It means that all vectors A, B, C, and D rotate on the same angle theta. Space-time CDONs can be represented in the other form. If we rewrite our CDON in the following form, then you can see that CDON consists of absolute Macfarlane quaternions, time Macfarlane quaternions, space Macfarlane quaternions, and space-time Macfarlane quaternions. So CDON can be represented as the space-time quaternion, where component of this quaternion is Macfarlane quaternions. Okay, space-time inversion. The time inversion is carried out using ET elements. If we multiply our initial CDON on ET elements, we obtain new CDON in which we have minus signs in space part and space-time part. Time inversion is carried out using space units, ER. In this case, we obtain new CDON in which we have minus signs in time part and in space-time part. And at last, the space-time inversion is carried out using ETR elements. In this case, we have new CDON in which we have minus signs in time part and space-time and space part. Okay, Lorentz transformation. The Lorentz transformation of CDON is carried out using so-called L operators. Here you can see the hyperbolic functions, and theta is defined as the ratio of velocity to speed of light. Vector m is the unit vector which is parallel to the vector of velocity. And the transformed CDON is obtained by multiplication initial CDON with L operators. Let us consider Lorentz transformation in detail. For example, we consider so-called four-vector of event. In this case, our CDON can be represented as time path and space path. Transformed CDON is written as the product of three terms. Here we assume Clifford product of vectors m and r. If we rewrite this expression in usual scalar and vector products, we obtain the following expression. And if we separate here scalar path and vector path and paths with different space-time properties, we obtain the following formulas for the transformation of coordinates and time, which is well known from relativistic physics. Some words about Sedenions. The 16-component object, space-time object, can be constructed using the algebra of Hamilton quaternions. In this case, A and E basis element is the imaginary units. The square of these elements are equal to -1. Okay. The more information about these objects you can obtain from our paper, which was published in Applied Mathematics. So, conclusion. A CDON is scalar vector spacetime object based on Macfarlane quaternion algebra. CDONs make it possible to take into account the properties of physical quantities in relation to the operation of spacetime inversion. As a conclusion, I would like to recommend you our book, Spacetime CDONs and Their Application in Relativistic Quantum Mechanics and Field Theory. This book is available from internet. You can see here the link to this book. Okay, and if you have any questions and if you would like to discuss something, you can write me using this email, please. Thank you very much for your attention.